Welcome back, everyone. This is the second section when we're talking about right triangle trig. We're going to talk about sine, cosine, tangent, and then secant, cosecant, cotangent. This should be a review again from geometry. Remember, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Sorry, this should say tangent, opposite over adjacent. Remember, the way to remember that is SOHCAHTOA. Okay? Sine, opposite over hypotenuse. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So let's try this one. I want to know the sine of angle A. Well, here's angle A. And remember, sine is opposite over hypotenuse. So that's going to be 12 over 20, which if you reduce your fractions down, will be 3/5. Cosine, adjacent over hypotenuse, 16 over 20, which will reduce down to 4/5. Tangent is opposite over adjacent. So 12 over 16. Well, that's going to reduce down to 3 over 4. Now let's do it for C, the other angle. Here's angle C. Sine is opposite over hypotenuse, so 16 over 20, which will reduce down to 4/5. Cosine is adjacent over hypotenuse, so 12 over 20, which will reduce to 3/5. And then the tangent of this angle is opposite over adjacent, so 16 over 12, which is 4/3. If you notice something, the sine of angle A is the same thing as the cosine of angle C. And the cosine of angle A is equal to the sine of angle C. And that's always going to happen. Also looked at the tangent of these things are just reciprocals of each other. What if I need to do it in a calculator? Make sure I'm in degree mode. So go to mode. Right now I'm in radian mode. I need to go to degree mode. If I want the sine of 62, that's pretty easy. Or the cosine of 60. Or the tangent of 79. I can always just use my calculator to find them as long as I'm in degree mode. We're generally going to round to 3 decimal places. Okay, so the calculator will do this math for you. There's also 3 reciprocal trig functions. There's secant, cosecant, and cotangent. Secant is abbreviated SEC. It's just 1 over cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Cosecant is 1 over sine, so it's hypotenuse over opposite. It's the reciprocal of sine. Cotangent, you also occasionally in older textbooks will see this written CTN for cotangent. It's 1 over tangent. It's opposite. Nope, that's wrong. So that's tangent right there. It's adjacent over opposite. So, let's find all 6 trig functions for each angle. So here's angle A. Sine, well that's opposite over hypotenuse, 4/5. Cosine, adjacent over hypotenuse, 3/5. Tangent, opposite over adjacent, 4/3. For these, I'm just going to use these and flip them. Secant goes with cosine, so it's going to be 5/3. Cosecant goes with sine, 5/4. Cotangent goes with tangent, 3/4. What about the other side of the triangle? Angle B. Well, there's the opposite side. Here's the adjacent side. And there's the hypotenuse. So sine's going to be 3/5. Cosine's going to be 4/5. And tangent's going to be 3/4. Secant goes with cosine, so I'm just going to flip cosine. Cosecant goes with sine. I'm just going to flip sine. Cotangent goes with tangent. I'm going to flip tangent. That was a really easy one because the numbers were small and didn't have to reduce fractions or rationalize any denominators or find any missing pieces. We can use trig to find the missing sides though, or the missing angles. Set up a ratio where we know at least two things. Then use the correct trig function in your calculator to solve. If you know two sides, you can find the third using the Pythagorean theorem. So let's take a look at this problem. I want to find x, and then I want to find the other missing side. We're going to go to 3 decimals. Well, here's the angle that I know. These are the two sides that I also am looking for. I know 3 things. What ratio is this? Well, I know the opposite and the hypotenuse. So that's sine of the angle equals the opposite over the hypotenuse. Now let's solve for x. If I just multiply the 17 over, now I can just type that in my calculator. 17 times 60 is 14.722. And then it says find the third side. Well, what's this side, the missing side? Well, I can do Pythagorean theorem. I know that 14.722 squared plus y squared has to equal 17 squared. If I subtract 14.722 squared, and then I take the square root of it, I can solve for y. Let's do all that in the calculator. So I've got the square root of 17 squared, I want to stay inside there, minus 14.722 squared, gives me 8.501. So y equals 8.501. And now I've solved my triangle. The only thing I haven't found is this angle, and we'll learn how to do that here in the next couple slides. What if we know the sides but not the angle? Well, we need some sort of function that goes in reverse. Like addition has subtraction, multiplication has division, powers have roots, exponentials have logs. We need some sort of inverse function for sine, cosine, tangent, secant, cosecant, cotangent. We have those and we can do them on the calculator. They're either called inverse sine, inverse cosine, inverse tangent, or you'll sometimes hear them called arc cosine, arc sine, arc tangent. They mean the same thing. So here's the relationship. If the cosine of an angle is 4/5, the way you get rid of cosine is you do cosine inverse of both sides. So cosine inverse, or I could write arc cosine, equals the angle that I'm missing. We can do it on the calculator. For example, the sine of some angle equals 0.1219. The opposite of sine, the way to get rid of sine, is sine inverse. If you do the sine of the sine inverse or the sine inverse of the sine, they're going to cancel out and you're just left with the angle. But I still have to do the sine inverse or the arc sine of the side. That is the exact answer. It's like square root of 2. We would just leave it as square root of 2. But if I want to know it to the nearest degree, or in this case, I guess I'll go to 3 decimal places. Second sine gives me sine inverse 0.1219. And the angle that I'm looking for is about 7. Pretty close to 7.002. So now 7.002 is the angle that has a sine of 0.1219. Let's try this as a problem. I need to find the missing angle, and then I'm going to solve the triangle. That means I need to find the missing angle that they should give me, and then find the other two missing angles. Well, here's x, and the ratio that I have is opposite and adjacent, so that's tangent equals opposite over adjacent. So I need to get rid of tangent. The way you do that is you do arctan, or inverse tan, and then 4/8. I know that's 1/2, but that's okay. I can leave it like that. So let's use my calculator. Second tangent to 4/8, 26.565. Now, I need to find the other things. I need to find this angle right here. I'm not going to use trig, I'm going to use basic geometry. I know that the three angles of a triangle have to add up to make 180, and I know that one angle is y. I know this angle is 90, and I just found this angle to be 26.565. Has to equal 180. So y has to equal 180 minus 90 minus 26.565. Grab a calculator. So it's 180 minus 90 minus 26.565. That angle is 63.435. 63.435. Yes. But I have one more thing to solve if I'm trying to solve the triangle. I found all three angles, but I still only have two sides. To find the third side, I'll call it z. I'm going to use Pythagorean theorem. So I know that 4 squared plus 8 squared equals z squared. So z has to equal the square root of 4 squared plus 8 squared. Let's use our calculator there. Well, we can do this mostly in our head. Z equals the square root of 4 squared is 16, 8 squared is 64. You add those together, you get the square root of 80. That's going to reduce down to, what will make that? 16 times 5. That ends up being 4 square root of 5. So the exact answer is 4 square root of 5. If we wanted to turn that into a decimal, if I ask it, I'm sorry, I hit the wrong button. 4 square root 5. If I ask it as a decimal, it's going to be 8.944. And double check yourself, does that make sense? Yes. That side's the longest side, the hypotenuse, and it's larger than the other two. So, review of basic geometry, sine, cosine, tangent. And SOHCAHTOA is the way that you can remember it. Solving a triangle means to find everything. Not always with trig, sometimes just by using basic geometry.